Hello and welcome to Explained. In today's episode, I'm going to try and explain in a nutshell how the universe was formed. Now, it's quite a complex process, so I'm going to use a metaphor to try and simplify the process a little bit. And if you think about the process of water damp that turns from a total vapor, a state of a gas, into a liquid, firstly a cloud-based liquid, and then from a cloud-based liquid it turns very often into a frozen state, snow, ice, hail, or anything of that nature. So the universe was formed in a much similar process where the equivalent to vapor is energy. We had which is a very conceptual idea, but energy being the vapor, right down into a solid state, which is matter that you and I use every day, and that the world that we live in is made of. So if we go to the original point, which is conventionally agreed upon as the Big Bang, about 13.7 billion years ago, there was this event where this intangible, odorless, conceptual idea of energy exploded. And within the first millionth of a second, this energy started to condensate, like water vapor will condensate into subatomic particles. So these subatomic particles are, amongst them, the Higgs boson, quarks, and other rather complex particles, not so easily explained in a 10-minute window or 10-minute video. But from that millionth of a millionth second right up to the 20th minute, you get the development of, call it the building blocks of what will eventually become neutrons, protons, and electrons. From the 20th minute, which is really hardly an elapse of time, up to about 47,000 years, this state of plasma between energy and a continuous creation of particles slowly starts to convert into what we know as elements, or the first element being a single proton element, namely hydrogen, and some of them, about 25%, turned into helium, lithium, and other smaller trace elements. 75% of them remained hydrogen. So up to 47,000 years after the Big Bang, you're into the state of plasma. And it's only after about 377,000 years after the Big Bang that you find the first stable elements. Now, up until that point, if you were to be able to, which is impossible, but if you were able to look into the night sky, you would see a cloud mass. It wouldn't be clear. Tonight, if we look up, we'll see a star and then nothing in between, and a star and a galaxy and nothing in between. But it wasn't like that. But in this time between 47,000 years and 377,000 years, as the building blocks gets used up, the cloud mass starts to clear up. much like when water vapor turns into cloud and disappear into rain. And forgive me if the analogy starts to break down, but essentially from about 377,000 years after the Big Bang onwards to about 100 million years after the Big Bang, when the first stars started to form, this soup, this plasma, starts to concentrate into clunks. The four forces have separated very early on after the Big Bang, one of them being gravity, and gravity starts to have its pull, and as it pulls, it combined with the momentum and the extraordinary expansion of the explosion, you start getting spin. And as this stuff spins like in a cake mixer, the pieces of matter start to stick together, and where they stick together you get star formation, which is what happens between 100 million and 200 million after the Big Bang. Stars that don't last very long, but they play their role in the ultimate stable universe that we see now. So that between 200 and 500 million years after the Big Bang, you now have this cycle of hydrogen and helium forming these clusters, which are stars, and they burn extremely hot. And as they burn so extremely hot, they also burn out quite quickly. And as they burn out quickly, a star that burns out does this strange thing. It inflates like a balloon, and then when it pretty much have used up all its energy, which is ever exploding atom reactions like an atom bomb, just at a scale thousands of times bigger than Hiroshima, as the star then uses up all its energy, it explodes into itself, and then in one last big explosion creates this flash of an explosion, which we call a supernova, and then pretty much dies into a red dwarf. Now that supernova, in that massive explosion, you get fusion, where single and double proton elements now fuses into multiple proton elements, like the metals we know, iron and gold, and pretty much all the elements in the periodic table is formed in that way, and they get scattered into the universe. And once again, gravity does its thing, because much like how the stars formed with spin, these things start to smack into each other. And we see remnants of that in Saturn, where there's still a belt of this stuff that's still smacking into each other. But about 9.1 billion years after the Big Bang, 9.1 billion years after the Big Bang, you get a couple of these elements, mostly iron, smacking into each other and forming what is today known as the Earth, who is 4.54 billion years old to be precise. So it's 9.1 billion years after the Big Bang, which is really, in our terms, 4.54 billion years ago. So the Earth is rather violent at this stage. Molten lava, it's still very hot. The whole process from when the Big Bang happened, everything is still cooling down. In fact, it's still cooling down today. But the Earth eventually cools down sufficiently that a crust forms. Much like if you were to cool down sugar, the outer crust starts to form. And as the outer crust starts to form, some of these elements starts to work together, and scientists aren't 100% sure where our water came from, whether it was upon the original formation of the earth or whether it was as a result of a comet smacking into the earth. We know that about 85 million years after the earth was formed, a big asteroid hit into us, taking about a third of the mass of the earth with it, and that is today our moon. And so this ever cooling earth then eventually gave birth to life, and life continued to grow for billions of years until about 255 million years ago the dinosaurs emerged, and they hung around till about 65 million years ago when they went extinct, and life continued. And we know that there are certain species that are reminiscent of the time of the dinosaurs. But around 255,000 years ago, we saw the genus Homo emerges, and we are part of that genus as Homo sapiens, but only at around 70,000 years ago are we seeing the first signs of constructive language in our own genus of Homo sapiens. And Homo sapiens have, ever since it first emerged on Earth, just increased in its capacity to learn and use and apply the resources of the Earth that was formed in this amazing way. And so this is a 3-part series. In part 2, I'm going to spend a bit more time explaining the formation of the Earth and the detail around the crust formation and everything that happened from 4.45 billion years ago up until now. In episode 3, I'll spend a little bit more time explaining how Homo sapiens eventually arrived to be on this planet and how Homo sapiens got to be where they are today. Quite a task to try and do in a shortish video, but that's what this channel is about, trying to explain complex stuff in an easy way, because that is what I like to do. If you like this video and you like the way that things are explained, why don't you share it with 2 people to see if they like it? And also, you need to make sure that YouTube understand what it is that you like. Because if YouTube understands what you like, it'll show you more of the type of videos that you like, and it will also know that people like this channel so that it can recommend it to more people. So like this video if you like it, hit the subscribe button so that you can be notified. Remember to hit the little bell that will notify you when a new video was made, and at the same time you're educating YouTube about the stuff that you like. So thank you for watching. My name is Louis van die Kerk, and I like it when things are explained, and I hope you do too. I'll see you in the next episode of this 3-part series. Thank you for watching.